There is a strange glow in the sky tonight, a soft, living green that seems to breathe in the dark. Astronomers call it 3I Atlas, the third interstellar visitor ever seen passing through our solar system. But this one feels different. Its light doesn't just shimmer, it whispers. For weeks, telescopes from Chile to Hawaii have watched it brighten, its emerald tail stretching against the quiet blackness of October. And though science has explanations, gases, sunlight, chemical reactions, there's something in the glow that science alone can't quite explain. Some say it's the reflection of our own curiosity, the color of life itself shining back from the void. Others believe it's a cosmic clue, a message written in wavelength and light. Whatever it is, the question remains the same. Why is it green? And perhaps, what does that color mean out there, where no life should glow at all? Tonight, let's travel beyond the headlines, beyond the formulas, and simply look, gently, at this strange visitor painting our sky. Because sometimes the universe speaks softly, and color is the only language it needs. It began quietly, as most remarkable things do. Just after dusk, when the horizon still held the day's last warmth, a faint emerald shimmer appeared above the eastern sky. At first, people thought it was a trick, maybe an airplane trail catching the light just right. But the glow lingered. Night after night it returned, growing brighter, stretching higher, almost like it was breathing. Telescopes confirmed what eyes suspected. The glow came from a visitor far beyond our neighborhood. Its name was 3I Atlas, a name too technical for something so quietly poetic. In small observatories and city rooftops, astronomers whispered to each other in excitement. They had seen comets before, icy travelers with tails of silver and blue, but never one that shimmered with such pure green intensity. The color wasn't neon or harsh. It was soft, like sea glass beneath moonlight. Cameras captured it, but the photos couldn't hold its feeling. That strange sense of watching something, both alive and ancient, drift across the sky. For a moment, even those who didn't believe in miracles found themselves wondering if this was one. Every generation has its cosmic messenger. Hale-Bopp in the 90s, Lovejoy in the 2010s, Swan in 2020. 3I Atlas now joins their lineage, but with one curious difference. It doesn't belong here. It came from another star system entirely. That realization made the green even stranger. This wasn't just sunlight bouncing off frozen water. It was light from a traveler that had crossed interstellar night, glowing a color we associate with forests, spring, and breath. Imagine that, a color of Earth, born far from Earth. And as nights passed, people began assigning meaning to it, as humans always do. Some called it a sign of renewal, others a warning, and others simply beauty without purpose. Yet beneath those interpretations, one truth held. Something beyond human hands was painting color across the sky again. The kind of color that reminds us that space, though cold, still has moments that feel warm. In the weeks to come, scientists would chase its chemistry, poets its meaning, and dreamers its memory. But tonight, as the green shimmer hangs like breath on glass, the only thing that matters is this. For a brief moment, the universe reached out, and it glowed. It was a teacher in New Zealand who first noticed the hue. He described it in his notebook as a faint green ghost above the sea. Soon after, backyard astronomers from South Africa, Chile, and Hawaii began posting similar photos, each slightly different, but with the same unmistakable color. Not the icy white of common comets. This was greener, deeper, something that seemed to carry its own light. Within hours, astronomy forums were alive again, the quiet hum of wonder spreading across continents like a gentle wave. Many of these first observers weren't professionals. They were people who just loved the night sky, retirees with telescopes, teenagers with phone cameras, couples out for late walks who happened to look up. The discovery felt shared, almost communal. The green visitor didn't appear in a single place. It appeared everywhere that curiosity still lived. That, perhaps, was its first gift. A reminder that discovery doesn't belong only to scientists. It belongs to anyone who still feels awe when the sky glows in colors we can't name. By the next morning, the data started flowing in. Orbital paths, magnitudes, chemical estimates. Observatories confirmed its motion was hyperbolic, meaning it wasn't bound to our sun. It would pass through and then leave forever, never to return. That simple fact made every observation precious, a once-in-a-lifetime chance to witness something truly passing through. Imagine watching a cosmic firefly blink once in the dark and then fade into eternity. What fascinated people most wasn't just its rarity, but the tone of its glow. Photographs captured it clearly, but the human eye sensed more than pixels could. Viewers said it felt alive, breathing, gentle. Scientists smiled at the descriptions, knowing that photons can't breathe, yet secretly they understood what people meant. Some lights don't just illuminate, they comfort. This green seemed to hold that kind of warmth. The same calm you feel watching bioluminescent waves roll in at night. And so, from quiet backyards to university observatories, humanity tilted its gaze upward once again. In a world often lit by artificial screens, we found ourselves looking at an ancient kind of light, pure, fragile, and infinitely far. The kind of light that asks for silence, not analysis. Because sometimes the best response to a mystery isn't an answer, it's stillness. Long before telescopes or data charts, people looked up and saw green in the sky, and it changed them. Ancient Chinese astronomers described jade stars that shimmered before dynastic transitions. In Europe, medieval monks wrote about emerald tails appearing during famines or wars. The Aztecs carved symbols of green fire into temple walls, believing they were messages from the gods. Color was never neutral to them. It was language. Green meant different things across cultures: life, poison, rebirth, or the bridge between worlds. When a green comet appeared, villages gathered in silence, priests watched in fear, poets wrote about the heavens bleeding color into night. They didn't know about carbon molecules or solar radiation, but they felt what we still feel, that quiet pull of curiosity wrapped in unease. Something about green in the void feels personal, like the universe wearing the color of forests, algae, and life itself. As time moved on, superstition gave way to science, but wonder remained. The Great Comet of 1861, Hale-Bopp in 1997, and Lovejoy in 2013 each stirred the same questions. Why this color? Why now? And even when scientists answered, explaining ultraviolet light, exciting diatomic carbon, the magic didn't fade. Because knowing how something glows doesn't make it less beautiful. It often makes it more so. The color green also carries a subtle psychological weight. It sits between blue and yellow, calm and warmth, logic and emotion. Maybe that's why it feels both soothing and unsettling in the sky. We associate it with Earth, with breathing, growing things. Seeing it above the atmosphere reminds us how fragile and improbable life really is. Perhaps that's the secret reason we can't look away when space glows green. Every comet, every passing emerald trail reminds us that the same atoms forming our bodies also burn across the heavens. Carbon, hydrogen, oxygen, ancient elements dancing in new forms. The light we see now began billions of years ago in stars that died to create us. Maybe that's what these comets are really showing us. Not prophecy, not omen, but a reflection of our own origin story told in color. A comet is a memory made of ice. Most of its life is spent asleep, drifting in the dark where sunlight never reaches. But when it nears a star, especially one as hot as ours, it begins to wake. The heat touches its surface, melts ancient ices, and releases gases trapped since the dawn of its birth. Those gases form a cloud, a coma, and as sunlight hits it, the molecules inside begin to dance. That dance is what we see as color. In the case of 3I Atlas, the main performer is carbon, specifically diatomic carbon, or C2. When ultraviolet sunlight strikes these tiny molecules, they absorb the energy and re-emit it in visible green. It's chemistry at its most poetic. Invisible energy becoming visible beauty. Every shade we see comes from vibrations, transitions, and quantum leaps happening millions of times per second. It's strange to think that something so cold can shine with such lifelike warmth. But light from comets isn't steady. It flickers, changes, sometimes even shifts hue. That's because the gases around them are constantly moving, colliding, ionizing. The colors you see tonight are not the same colors you'd see tomorrow. It's like watching an artist repaint the same canvas again and again, using the same brush, but new emotion each time. This living quality is part of what makes comets hypnotic to watch. Even scientists admit they feel a strange connection to them. These ancient leftovers from creation, still glowing, still unpredictable. 3I Atlas reminds us that not everything in space is dead or static. Some things still breathe, in their own way, through light, through reaction, through resonance. And so while the textbooks explain the mechanics, the soul of it feels different. The glow is not just chemistry, it's memory illuminated. Every green photon leaving that comet carries a story of creation, of distance, of energy transformed. And perhaps if you look long enough, you'll see more than science. You'll see the quiet persistence of something that refuses to be forgotten. When scientists talk about a comet's chemistry, they sound almost like poets reciting ingredients for a spell. Water ice, ammonia, carbon monoxide, formaldehyde, methane. Each molecule a fragment of cosmic history. Together they form what astronomers call a dirty snowball. But that phrase hardly captures the truth. Because within that frozen mixture lies the chemistry of stars, planets, and possibly the first sparks of life itself. The green of 3I Atlas begins deep within that mix. Ultraviolet sunlight tears apart carbon molecules, splitting bonds and creating fragments that recombine into glowing diatomic carbon. In the vacuum of space, those reactions unfold freely, unbothered by air or gravity. Each tiny reaction adds another whisper of light until the comet glows visibly to us across millions of miles. And when you realize that, you start to see the glow as more than color. It's communication, molecule to molecule, across the void. Spectrographs show delicate lines, sharp spikes of green and cyan, proof of this ongoing chemistry. But behind the data lies something quieter, a sense of rhythm. The comet isn't just reacting, it's performing, releasing energy in waves as if pulsing in harmony with the sunlight that feeds it. It's strange, isn't it, how even lifeless things seem to find rhythm when touched by light. Some researchers suspect that the exact hue of 3I Atlas might reveal the presence of unusual compounds, maybe interstellar isotopes or molecules never seen in our system before. If true, then that green isn't just beautiful, it's a signature of another world, another chemistry entirely. Every shade of green becomes a message in a language we're still learning to read. And so beneath the quiet poetry of the sky lies the deepest science, the alchemy of light, chemistry, and distance. When you look up at that faint emerald glow, You're not just seeing a comet, you're watching energy become beauty. You're watching matter remember the stars it once belonged to. And that is a kind of magic only the universe could make. When astronomers realized 3I Atlas was not from our solar system, everything about its glow took on new meaning. It wasn't a local traveler stirred awake by our sun, it was a messenger from another star. That's what the I in its name means. Interstellar. It had drifted across the galactic void for millions of years before wandering into our cosmic neighborhood. And with that discovery, the mystery deepened, because no one really knows what chemistry a traveler from another system might carry. Unlike most comets, which circle our sun in long, frozen loops, 3I Atlas is on a one-way journey. Its path is hyperbolic, a curve that bends but never closes. It will visit once, glow, and then vanish forever. That idea alone gives its color a strange poignancy. This green light we see now has never shone here before and will never return again. It is, in every sense, a once-in-a-civilization shimmer. Its interstellar nature also raises questions about its ingredients. Maybe its carbon isn't quite like ours. Maybe its ice formed under a different kind of star. Maybe the cosmic radiation of its home system gave its molecules a subtle shift in behavior. Every detail about its chemistry might carry a fingerprint from elsewhere, and in that way, every photon it emits is a clue. Scientists know this isn't the first interstellar visitor. Before 3I Atlas came Oumuamua and then Borisov, but this one feels different. It behaves more like a comet than a rock, more alive than inert. Its tail, its color, its responsiveness to sunlight, all suggest an active, breathing object. That's why its glow matters. It's the first true conversation we've had with interstellar material that speaks in color, not in silence. When you think of it like that, the green feels symbolic. A bridge between one star system and another, a shared spectrum across the galaxy. The color of 3I Atlas isn't just light. It's memory crossing the distance between suns. Before that light ever touched our eyes or our telescopes, it traveled through an ocean of dust. Interstellar space isn't empty. It's filled with faint clouds of charged particles, ancient smoke from long-dead stars. As the green photons left the coma of 3I Atlas, they began a long swim through this medium, scattering, bending, softening. By the time they arrived here, their edges had blurred slightly, their hue mellowed, like a memory retold across generations. Astronomers call this effect extinction, the dimming and reddening of light as it passes through cosmic dust. But in the case of 3I Atlas, something unusual happened. The color didn't redden much. It stayed remarkably pure. That suggests the dust between stars barely touched it, or perhaps the particles surrounding the comet itself shielded it somehow. It's as if the glow wanted to remain green, no matter what the universe threw at it. That resilience fascinates physicists. Green light, with its specific wavelength around 520 nanometers, is easily scattered. For it to survive a journey across interstellar space without fading means the source was bright, persistent, maybe even unusually energetic. Could something about the comet's composition amplify the emission? Could its plasma environment act like a natural lens, focusing the glow forward? These are questions scientists still whisper about. To the human eye, though, those technicalities melt away. What we see is simple and ancient, a tiny green spark drifting across the dark. That spark has traveled longer than humanity has existed. It has passed through the ruins of supernovae, through fields of dust and invisible radiation, through distances our language can't describe, and yet it arrives. Gentle, steady, alive. So when someone looks up tonight and wonders why it feels emotional to see a faint green blur, the reason may be hidden in the journey itself. That light has endured everything that emptiness could offer, and still it glows. Perhaps that's why it moves us so much. At first glance, 3I Atlas behaves like a normal comet, a nucleus of ice and rock, a coma, a tail, but its glow doesn't fit neatly into that category. When compared side by side with comets like Lovejoy or Neowise, the difference is subtle yet undeniable. The green from 3I Atlas looks deeper, as if it carries an undertone of blue or gold, depending on the hour. Some astronomers call it metallic green, others emerald fire. No one can quite agree on what it looks like, only that it feels different. One theory suggests its unusual orbit exposes it to magnetic fields in a way local comets never experience, traveling through regions where the sun's magnetic current changes polarity could alter how its gas emits light. Another idea is that its molecules, forged in another stellar nursery, have slightly different isotopic ratios, changing the way they fluoresce under solar radiation. In short, it might literally glow differently because it was born under another star. Observers also noticed that its brightness curve doesn't behave like a typical comet's. Instead of peaking predictably and then fading, it pulses, bright one night, dimmer the next, almost as if it reacts emotionally to sunlight. Of course, that's just metaphor, but it captures what many astronomers feel watching it. It's as though we're observing something learning how to shine in a new environment. Photometric data confirm microbursts, small outgassing events that spike its brightness for hours. Each time, the hue changes slightly, suggesting complex chemistry at play. Some believe we're seeing unfamiliar compounds fluoresce, perhaps cyanogen cousins or nitrogen chains rarely seen before. In that sense, the glow of 3I Atlas isn't just strange. It's educational, revealing new chemistry, one flare at a time. Maybe that's why it feels not normal. Not because it breaks physics, but because it reminds us that even the most universal rules have room for personality. Each comet has its own fingerprint in light, and this one simply writes its name in a color the universe doesn't use often. That's why we notice it, because it's different enough to make us wonder what else might be out there, glowing in ways we haven't yet seen. Once the excitement settled, a quieter argument began. Was 3I Atlas truly green, or was it simply our eyes and cameras tricking us? Color in astronomy can be deceptive. Space photographs often exaggerate hues for clarity, and long exposure sensors sometimes amplify faint wavelengths until they appear brighter than they really are. Could the emerald glow be a side effect of how we look, rather than what's actually there? To answer that, teams compared spectral data from multiple observatories. Chile, Hawaii, and Japan all saw the same emission lines, the telltale twin peaks of diatomic carbon. That means the green isn't artificial, it's physical. The molecules really are fluorescing in that range, but there's nuance. Human perception of green varies under darkness. Our eyes shift toward blue sensitivity at night, making certain cyan hues appear greener. So the color may be real, but our brains might deepen it emotionally. That mix of science and psychology fascinated researchers. They realized that what we call the color of a comet is both a physical property and a human experience. It's photons and perception. The universe gives the light, we give it meaning. Together they create what we call color. Still, some skeptics remained cautious. They pointed out that comet tails often include a mix of gases, some emitting green, others red or blue. Depending on which dominates at a given moment, a camera might pick up an average tone that looks green overall. That doesn't make it fake, it just means the truth is layered. Even color, the simplest thing we see, is built from complexity. In the end, the debate only deepened the beauty. Whether the glow is pure green or a blend, whether it's physical or perceptual, it exists, and it moves people. Maybe that's the real answer science can't quantify. That light can be both a measurement and a feeling, both data and dream. And perhaps that's what keeps us looking up at it night after night. By late September, observatories in both hemispheres had locked onto 3I Atlas. The Atacama Large Millimeter Array in Chile and the Subaru Telescope in Hawaii coordinated observations, forming a cross-planetary watch. The data came in slow waves, spectra, brightness curves, gas emissions, each one adding another note to the growing symphony of discovery. The first results surprised everyone. The comet wasn't just glowing, it was singing in radio frequencies too faint for human ears. Those frequencies suggested ion interactions between the comet's gas and the solar wind. When carbon compounds ionize, they emit both visible and radio waves. It's like hearing color through another sense. The instruments captured delicate oscillations, patterns that repeated with each rotation of the nucleus. It was as if the comet had a heartbeat, a steady rhythm echoing through vacuum. Meanwhile, infrared data revealed a complex mix of volatiles: water, ammonia, methane, and something unclassified. The unidentified spectral line drew quiet excitement, perhaps a molecule unknown in our system, maybe a clue to how chemistry unfolds under another sun. Even if it turns out to be a known gas in an unfamiliar ratio, it will still teach us how universal or unique molecular evolution can be. On the optical side, high-resolution imaging showed jets of material spiraling from the nucleus, forming patterns not seen in ordinary comets. One jet curved sharply, possibly due to electromagnetic interaction with the heliospheric current sheet. That means 3I Atlas isn't just shining, it's responding. Space isn't passive for it, it's participatory, like a dance partner shaping every motion. Those first nights of data brought more than measurements, they brought mood. The scientists in both observatories reported feeling something they couldn't define, the sense that they were watching not an object, but a story unfold in real time. And maybe that's what makes discoveries like this unforgettable. They remind us that in the quiet hum of machines collecting light, we're really listening to the universe remembering itself. At the heart of the mystery lies a molecule so small yet so expressive, diatomic carbon, or C2. To most of us, it's just two carbon atoms bonded together, invisible and simple, but under the right light, ultraviolet sunlight, becomes an artist, painting the sky in shades of emerald. This is the same molecule responsible for the green hues in many comets throughout history, but in 3I Atlas it seems unusually dominant, as though the comet's entire personality radiates through this single molecule's shimmering signature. Here's how it happens. When sunlight, especially in the ultraviolet spectrum, hits the gases surrounding a comet, it excites the electrons within these carbon molecules. As the electrons drop back to their lower energy states, they emit light, specifically in the green part of the visible spectrum. The process is called fluorescence. What's fascinating about 3I Atlas is how efficient this process seems to be, almost as if the comet was tuned to emit green light more vividly than others of its kind. Some astronomers think this could mean the comet carries an unusually high concentration of C2 gas, or that its coma, the glowing envelope surrounding its icy core, is denser than expected. Others suspect that the energy from solar radiation is interacting with the gases differently due to the comet's interstellar makeup. In other words, 3I Atlas might be reacting to our Sun like a first-time visitor, unsure of how to handle the heat and shining brighter because of it. The discovery has reignited conversations about the chemistry of life itself. Carbon is the backbone of every living thing we know, and here it is again, performing in the emptiness of space, glowing green as if reminding us of our shared foundation. It's humbling to think that the same element making up our bodies is the one making distant ice come alive under sunlight. In this way, the comet becomes a mirror of life, showing that beauty doesn't require consciousness, only chemistry. That even in the silence of deep space, something as small as 2 carbon atoms can sing in color, turning invisible radiation into visible wonder. It's a quiet conversation between light and matter. And tonight, we get to listen. When sunlight travels through space, most of its energy goes unseen. The majority of its strength lies in ultraviolet radiation, invisible to the human eye, but potent enough to wake sleeping matter. When that light reaches a comet like 3I Atlas, something magical and deeply physical begins to happen. The frozen surface of the comet starts to sublimate, turning directly from solid to gas. As the gases escape, ultraviolet light strikes their molecules, energizing them. The atoms inside those molecules begin to vibrate, spin, and rearrange, sometimes breaking apart, sometimes bonding anew. In those transitions, energy is released as light, the green, the blue, the faint red threads we see glowing in photographs. To the universe, this is ordinary physics, but to us, it feels like resurrection, dead ice turning to luminous breath. Each comet reacts differently to sunlight depending on its chemistry. For local comets, the gases have danced with our sun countless times, the patterns familiar, the glow predictable. But for 3I Atlas, this was a first encounter. Its gases were untested, its reactions unmeasured. That's why the colors feel so unusual, so alive. The molecules were seeing our star for the first time, and in that encounter, something primal occurred, energy becoming light for the first and perhaps only time in this form. If you think of sunlight as a kind of universal artist, ultraviolet is its secret brush, unseen but transformative. It reveals what's hidden, it animates what's frozen. Every shade of green we see tonight began as invisible energy millions of kilometers away. And though we can't see the process itself, we witness its poetry. The afterglow of invisible forces meeting matter for the first time. Maybe that's what makes this all so hauntingly beautiful, that everything luminous starts in the unseen. Just like our thoughts, just like dreams, light begins invisible, and only becomes visible when it touches something ready to shine. While most eyes on Earth were fixed on the sky, another silent witness was watching from afar, Mars. As 3 Atlas continued its trajectory, its path brought it close to the red planet's orbit, just outside its gravitational influence. To human observers, it was just a line on a chart, but to the cosmos, it was a meeting of worlds, a delicate brush of paths that carried quiet tension. Telescopes on Mars orbiters began to pick up faint disturbances in the surrounding plasma field. Nothing violent, nothing dramatic, just a subtle rise in charged particle density near the region where 3I Atlas passed. Some scientists believe this was a natural reaction between the comet's ionized gases and the solar wind bouncing off Mars' magnetic remnants. Others think it could have been something more, a kind of electrical conversation between the two travelers, exchanging silent sparks across the void. To imagine it visually, picture a thin green mist drifting past a rust-colored planet, the two bathed in the same sunlight, their shadows stretching into infinity. No explosion, no collision, just a cosmic nod between strangers who happen to meet in the same orbit for a moment in eternity. It's quiet, almost tender, the kind of beauty that hides in stillness, not spectacle. From a scientific view, these interactions are valuable. They teach us how solar radiation behaves near unmagnetized planets and how interstellar material influences local plasma environments. But there's also something emotionally stirring about it. The idea of a comet from another star system passing near a world that might one day host human life. Two symbols of exploration, one ancient, one potential, meeting in the same space. As 3 Atlas drifted beyond Mars' orbit, its glow didn't fade, it deepened. Observers reported the green becoming richer, almost golden at the edges. Perhaps it was the sunlight angle, or perhaps, like a performer nearing the end of a song, it was giving us one last verse before disappearing beyond reach. Our solar wind is an invisible river of charged particles, a stream of protons and electrons constantly flowing from the sun. Everything it touches feels its pressure, its warmth, its invisible push. But when it meets an interstellar object like 3I Atlas, the reaction is different. It's like two languages meeting for the first time. Local comets have magnetic habits. Their ices, their dust, their tails all respond predictably to solar wind. They form elegant curves and smooth plumes, always facing away from the sun. But 3I Atlas, it twitched, bent oddly, and sometimes shimmered in ways that confused simulation models. The solar wind seemed to stir it unpredictably, like a gust hitting fabric instead of stone. That randomness fascinated astrophysicists. It suggested that the comet's particles might have different electrical charges or masses, creating turbulence at a microscopic scale. When scientists mapped its plasma tail, they found subtle ripples, fluctuations that look like heartbeat patterns. Some called them breathing waves. They may have formed as the interstellar materials met solar ions and tried to stabilize, creating temporary harmonics in magnetic fields. In simpler words, the comet was singing back to the solar wind, adjusting its rhythm to match a new kind of energy, almost like the universe improvising music through physics. This isn't just poetic imagery, it's measurable. Instruments detected oscillations, low-frequency waves traveling along the tail. They weren't strong enough to affect the orbit, but clear enough to prove that something new was happening, a kind of electromagnetic handshake between systems. If true, it means interstellar comets can literally vibrate differently from those born near our sun. It's humbling to think that space, which we imagine as silent, might actually be full of these quiet songs. Invisible harmonies between wind and dust, charge and motion. Perhaps that's why watching 3I Atlas feels emotional to so many, because somewhere deep down, even if we can't hear it, our atoms remember the same cosmic music. One of the strangest observations about 3I Atlas came from deep space telescopes studying its coma, the glowing halo around its icy nucleus. Light seemed to behave oddly near it. Instead of spreading evenly, some rays curved slightly, creating a faint halo within halo effect, like light caught in a slow whirlpool. Scientists began to suspect that the comet's magnetic environment was doing more than they thought. Every comet generates a small magnetic field as its charged gases move. Normally, this field is too weak to affect visible light, but interstellar objects may carry stronger or differently structured magnetism. 3I Atlas's field might be twisting photons in subtle ways, not enough to create gravitational lensing, but enough to distort the scattering angles of green light. That could explain why its glow looks more alive, more layered, almost liquid. In laboratory simulations, charged carbon gases placed in magnetic fields produce similar halo-like effects, flickers that shift color slightly with every pulse. This could mean 3 Atlas is wrapped in a self-sustaining electromagnetic cocoon where light doesn't simply escape, it dances. To our eyes, this would appear as gentle variations, a glow that breathes, expands, and contracts like a living organism. Observers described it as wavy or thick, But maybe what they saw was physics expressing itself aesthetically. It's one of those rare times where scientific data and artistic perception overlap perfectly. The math and the beauty are the same thing. If the theory holds, it means that light isn't always a straight messenger. Sometimes it curves, it wavers, it adapts to the fields it crosses. Just like our understanding of the universe, never rigid, always bending with new discovery. And as we study that glow, we're not just learning about comets. We're watching the rules of light being gently rewritten, one emerald shimmer at a time. Just as 3I Atlas reached its brightest point, the sun began to stir. Giant solar flares erupted from its surface, sending waves of charged particles racing outward through space. By what seemed like perfect timing, those storms intersected the path of the green comet. To some it felt like coincidence, to others like choreography, as though the universe had timed this meeting for a reason. The solar storm struck the comet's tail first, igniting it with an unexpected burst of brightness. Cameras around the world captured the moment. The green intensified, flared briefly into gold, and then settled back into calm. Scientists were quick to explain. Solar wind interacting with ionized gases can excite new emission lines, producing momentary shifts in color. But even they admitted quietly that the synchronization was stunning. For a few hours, it was as if the sun itself had reached out to greet this interstellar visitor. Every particle from that storm carried magnetic information, fingerprints of the sun's energy. When those particles collided with the gases around 3I Atlas, they temporarily rewrote the comet's glow. Like sunlight meeting alien chemistry, a brief dialogue unfolded in color. Green deepened, cyan threads appeared, and then the emerald faded back, leaving scientists wondering what secrets those colors might have carried. For ancient cultures, such an event would have been seen as divine, a star's light awakening another star-born traveler. Today we call it plasma interaction, yet the feeling remains the same. When the sun and a comet perform in tandem, it reminds us that space is not empty. It's alive, responsive, woven with energy and timing, too precise to be dismissed as random. Perhaps it's just physics, or perhaps, as some astronomers whispered that night, we're witnessing the hidden rhythm of the cosmos, moments when matter, light, and motion align just enough to show us that even chaos has choreography. Long before 3I Atlas lit our sky, others came before it, messengers of green fire that sparked awe and curiosity through centuries. In 2011, Comet Lovejoy streaked across the southern hemisphere, glowing with an intense teal aura that stunned scientists. In 2020, Comet Swan followed, trailing a bright green tail visible to the naked eye. Even Hale-Bopp in 1997 carried hints of green across its enormous coma. Each time, people asked the same question: why green? Why always this color? The answer, of course, lies in chemistry, the same diatomic carbon glowing under sunlight. Yet every comet's green feels a little different. Lovejoy's was electric, Swan's was soft, Hale-Bopp's faint and misty. 3I Atlas's, however, feels deeper, almost emotional. Maybe it's because we now understand its origin beyond our solar system. When something foreign glows familiar, it hits differently, like hearing a song from your childhood played on an alien instrument. Looking back through history, these green visitors always seem to arrive during moments of human reflection. After wars, before technological leaps, during collective awakenings. Coincidence, perhaps, but it gives the phenomenon an air of mystery. Our ancestors recorded them as omens, we record them as data. Yet beneath both lies the same instinct, to look up and feel something when color appears in the dark. Each green comet has added a verse to our cosmic story, Lovejoy taught us about solar survivability, Swan about fragmentation, Hale-Bopp about long-period orbits. 3i Atlas now adds interstellar chemistry to that list. And maybe something more, perspective. It reminds us that beauty isn't local, it's universal. The same physics that colors comets also colors the auroras above Earth, the algae in our oceans, the life in our forests. The palette of existence repeats across scales. So when we gaze at 3i Atlas, we're not just seeing another green comet. We're seeing a continuation of a cosmic tradition, written in light, spanning centuries. Each glow is a reminder that wonder itself never ages. There's an odd trick our biology plays when the world gets dark. Our eyes contain two kinds of cells, cones for color and rods for night vision. When daylight fades, cones rest and rods take over. The catch is, rods can't detect color very well except faint shades near green. That's why in twilight, green often feels more vivid, more alive than any other color. When people describe 3i Atlas's glow as breathing or gentle, they might not realize they're describing their own perception. Our eyes amplify green at night. It's nature's way of helping us see life even in low light. Maybe that's why the comet's glow feels emotional. It's not just physics, it's physiology. The universe sends light, and our eyes make it personal. Under telescopic lenses, 3i Atlas's green is measurable, around 520 nanometers in wavelength. But to the human observer standing beneath a quiet sky, that wavelength becomes sensation. It feels softer, rounder, almost sentient. There's something primal in it, as if the body recognizes green as the color of safety, of growth, of home. Seeing it floating in the black void makes it surreal. A living color where no life should be. Even seasoned astronomers admit this. Many describe a strange comfort when watching green comets. A sense that the color is familiar, almost protective. Perhaps it's evolutionary memory, or perhaps it's something deeper. An echo of the first forests, the first moss, the first sparks of life that ever reached for sunlight. When the same hue appears millions of miles away, it awakens something ancient in us. So maybe the strange magic of 3i Atlas isn't in its chemistry alone, but in how it interacts with us. It's a collaboration between cosmos and consciousness, photons meeting neurons, turning the coldness of space into the warmth of experience. That's not illusion, that's connection. Before telescopes and laboratories, the color green in the heavens carried weight far beyond science. To the Egyptians, green was the color of rebirth, the skin of Osiris, god of the afterlife. When green lights appeared in the sky, they believed it marked renewal, not destruction. To the Chinese, jade comets symbolized balance between heaven and earth. The Norse saw emerald streaks as the spirits of ancestors guiding travelers through the cold. Each civilization, in its own way, gave meaning to the same glow we now call diatomic carbon. When 3i Atlas appeared, it stirred something old in humanity's imagination. Despite all our knowledge, the instinct to mythologize remains. Social media filled with phrases like heaven's lantern and the messenger of renewal. It's remarkable how our language still leans toward poetry when science falls short of explaining emotion. Perhaps that's the real continuity, the heart's refusal to see light as just wavelength. Ancient texts often describe green comets as bearers of transition, symbols of endings and beginnings. Sometimes they preceded floods, other times revolutions. But even then, the tone was rarely purely fearful. Green, in myth, has always carried both life and mystery. It's the color of healing and poison, of growth and decay, a reminder that creation and destruction often share the same hue. As 3i Atlas passed silently overhead, millions unknowingly revived that ancient tradition, watching, interpreting, feeling. We may no longer gather in temples to pray beneath the glow, but we still pause, we still wonder. And in that pause, we connect with the same timeless awe our ancestors once felt. The technology has changed. The reverence has not. Maybe myths aren't meant to be replaced by science. Maybe they're meant to stand beside it. Two languages telling the same story in different tones. The story of humans looking up, trying to make sense of beauty too big to hold. In quiet observatories and late-night research calls, a new question began to surface. What if 3I Atlas carries chemistry we've never seen before? It sounds sensational, but to some scientists it's a logical hypothesis. The comet didn't form here, it formed light years away under a different star in an environment with its own radiation and elements. The ratios of carbon to nitrogen, oxygen to hydrogen could be slightly different, enough to shift the way it glows, reacts, even smells, if comets had a scent we could reach. Spectroscopic readings from multiple observatories hinted at faint, unfamiliar lines in the spectrum, tiny signatures that didn't quite match known molecular patterns. Some researchers speculated they might be exotic isotopes, molecules that decay differently, or even compounds that could only form in colder, denser nebula. It wasn't proof of anything alien, just chemistry, foreign to our solar system, but even that in itself is extraordinary. Because if those signatures hold true, it means that the green light we see tonight comes not only from different molecules, but from different histories. Each atom inside 3I Atlas might have been born in a star that died before our sun even existed. That light we call green could be the echo of another civilization's stardust, not intelligent life, but chemical ancestry, speaking across interstellar time. Theories spread quietly in forums, conferences, back-channel discussions. Some wondered if the strange glow could be influenced by metallic ions or superconductive dust. Others thought it might hold clues about prebiotic molecules, the building blocks of life, scattered across galaxies like seeds waiting for fertile worlds. Nothing confirmed, everything possible. Science moves slow, but imagination doesn't, and maybe that's the beauty of it, that a single green glow could spark so much speculation. Whether 3I Atlas carries alien chemistry or just rare combinations of familiar ones, it reminds us that the periodic table isn't just numbers and letters. It's a symphony still playing, still discovering new notes. Perhaps 3I Atlas is simply one of those notes, softly humming from a star we've yet to meet. In the quiet hours of observation, scientists began to wonder if 3I Atlas might hold secrets no comet before it ever could. What if, inside that glowing emerald mist, there existed elements we'd never encountered, atomic structures forged under a different star's rules? It's not impossible. Our periodic table is a record of what we have found, not necessarily of all that exists. Other solar systems with different pressures, magnetic fields, and cosmic histories could easily birth matter that behaves unlike anything we've catalogued. Some researchers suspect that the distinct hue of 3I Atlas may come from trace metals interacting with carbon-based gases, perhaps exotic isotopes of nickel, chromium, or even unknown variations of transition elements. These could subtly shift how energy is absorbed and released, changing not just brightness but tone. In essence, its color might be an accent from another star's chemistry, written in green instead of gold. To test these theories, astronomers used high-resolution spectrographs to read the comet's light line by line. Most wavelengths matched familiar compounds, but here and there, faint, narrow bands appeared where none should, too soft to confirm, yet too clear to ignore. They weren't artifacts of the instruments. They were something real, whispering from the edges of known science. It's humbling to think that Floating quietly in space, a chunk of ice and rock might carry the next great clue to how matter forms. Maybe 3I Atlas is not just a traveler. Maybe it's a messenger, carrying chemical stories from a sun that died long before ours was born. If so, every flicker of its glow is a syllable from another cosmic language, one that speaks in light, not words. And so, night after night, telescopes kept watching, waiting for the next tiny spectral anomaly. Because even a small deviation could rewrite what we think we know about the building blocks of the universe. Perhaps one day, when we hold samples from another star, we'll recognize this green hue as the first whisper of a much larger truth. There's a growing suspicion among astrophysicists that the glow of 3 Atlas might not come from its gases alone, but from the dust it carries. Interstellar dust is not like the dust of our solar system. It's older, sharper, often coated with exotic compounds that survive the radiation of deep space. When sunlight touches it, it might scatter or refract light in ways that make colors appear warmer, softer, or altogether alien. Imagine sunlight filtering through a stained glass window. Every pane shifts the hue differently. In a similar way, each grain of interstellar dust can bend light just slightly, changing its emotional tone. The dust on 3I Atlas may be ancient, billions of years older than our Sun, shaped by supernova shockwaves, enriched with metals from dead stars. That means its reflective properties could be utterly unique. Infrared telescopes detected thermal emissions from the comet that didn't fully match known dust compositions. The particles seemed to heat up faster and cool down slower, suggesting a dense, perhaps metallic surface texture. Such dust might not just reflect green, it might amplify it, acting like microscopic mirrors, catching and re-emitting light with enhanced brightness. That could explain the comet's deep emerald tone, even when it was far from the sun's direct glare. If true, then what we're seeing isn't just gas fluorescing, it's sunlight made strange by memory. Each dust grain, a relic of long-dead stars, still glowing faintly, as if unwilling to forget where it came from. The idea is poetic, but grounded in physics, energy absorbed long ago, released again across space, carrying its own soft signature of time. So perhaps the green of 3I Atlas isn't new at all. Perhaps it's ancient light, recycled through cosmic dust, shining once more after a billion-year journey. The universe has a way of making even decay look beautiful. If the universe is a symphony, then spectroscopy is how we learn to read its notes. Every element, every molecule leaves a distinct pattern in light, a barcode of energy. By spreading the light of a comet through a prism or diffraction grating, scientists can see which wavelengths are missing or enhanced. Those patterns reveal the chemistry behind the glow. No samples needed, just photons. For 3I Atlas, the spectral readings were both familiar and foreign. The strong green emission lines of diatomic carbon dominated as expected, but faint fringes appeared at wavelengths slightly off from known patterns. Subtle shifts hinting at unusual isotopes or interactions. Each line was like a heartbeat, a pulse of information traveling millions of kilometers to tell us what the comet was made of. Spectroscopy doesn't just identify elements, it tells stories. The width of a line shows motion, its sharpness reveals temperature, its symmetry tells of turbulence or calm. Through this, scientists can reconstruct entire environments from mere color. And in the case of 3I Atlas, the story it told was one of complexity, layered gases, overlapping emissions, and constant change. There's an art to reading those lines, a kind of musicality. Astronomers often describe spectra as songs of light. The song of 3I Atlas was rich in harmonics, shimmering between known frequencies like a voice trying to say something beyond our vocabulary. Every observation deepened the melody, confirming that this wasn't just a comet, but a chorus of chemistry playing across the vacuum. Perhaps one day, when technology allows, we'll capture its spectrum in full, every note, every beat, and realize that even color has language. Until then, each telescope on Earth keeps listening to its song, letting light write science across our imaginations. Not all telescopes watch with eyes. Some listen with ears. Across Chile, Hawaii, and Spain, radio observatories tuned their dishes toward 3i Atlas, hoping to detect the faint electromagnetic whispers that comets emit as their molecules collide. At first, the data came back silent. Then, slowly, patterns emerged, rhythmic pulses, soft hums in the microwave band. It wasn't communication, not in any human sense, but it was structured, repeating, alive in its own language of frequency and time. Those signals told of gas densities, ion interactions, and spin rates deep inside the coma. Each tiny oscillation carried information: how fast the nucleus rotated, how charged particles bounced off magnetic boundaries. It's astonishing that we can measure such details from millions of kilometers away using nothing but echoes of invisible waves. Yet even more astonishing is the mood it creates. The feeling that the universe itself is humming softly while it moves. Late at night, technicians monitoring those signals often describe them in musical terms. One called it a lullaby of plasma. Another said it sounded like a heartbeat fading in fog. Of course, the data is just numbers. But the human mind can't help but translate numbers into feelings. The same way we hear rhythm in raindrops or melody in the hum of an engine, we hear emotion in data when it's beautiful enough. Radio telescopes picked up a curious modulation, a periodic wobble that repeated every few hours. It could be the comet spinning or waves bouncing between layers of ionized gas. But one researcher poetically called it the comet's voice. Perhaps not a literal sound, but an electromagnetic rhythm, a reminder that everything in the universe vibrates, even ice, even dust, even silence. And somewhere in that hum, we might find new physics waiting. Because when the universe sings in frequencies we don't expect, it's often trying to tell us something we've never heard before. If you could float beside 3i Atlas right now, no engines, no radio, just drifting, the first thing you'd notice wouldn't be its glow, it would be the silence. The kind of silence that's not empty, but full. In deep space, sound doesn't travel, but light does. The only noise is what you bring with you, your heartbeat, your breath, your thoughts. Around you, the green shimmer expands gently, particles drifting like glowing dust in water. It's not loud, but it feels alive. The vacuum of space isn't void, it's presence without pressure. The comet's coma expands in all directions, each molecule tracing slow, invisible arcs under sunlight. The light scatters softly, and for a brief moment, you'd feel like you were standing inside a living cloud of color. The silence gives the illusion of stillness, but everything is moving. Every photon, every atom, every piece of light making its quiet escape into eternity. There's something profoundly humbling about realizing that even here, in the loneliest stretch of the cosmos, beauty continues without witness. The comet doesn't glow for us. It glows because that's what it was made to do. Whether anyone sees it or not, it still performs, an ancient instinct written into its chemistry, playing endlessly for the stars. Astronauts often describe space as loudly silent. That's what this would feel like. The absence of sound replaced by the presence of everything else. The hum of radiation, the flicker of particles, the slow pulse of light that feels like thought. 3i Atlas drifts in that soundless symphony, its green halo spreading wider with each passing hour, until the edges blur into darkness. And perhaps that's where its true beauty lies, not in being seen, but in existing. A traveller from another star, glowing softly in the quiet sea between worlds, unconcerned with meaning, unconcerned with time, just being radiant, just being itself. For as long as humans have had eyes to see, green has meant one thing above all: life. It's the colour of moss after rain, of forests breathing after dawn, of rivers curling through valleys. To see that same colour shining in the cold silence of space feels almost contradictory, as though life itself has escaped the boundaries of biology and found a way to exist in pure light. When we look at 3i Atlas glowing softly against the black, something deep inside us recognizes that color, and it stirs an emotion older than language. We don't expect green in the void. It feels misplaced, almost rebellious. Warmth against coldness, vitality against endless night. And yet, maybe that's why it feels sacred. The universe, indifferent as it is, somehow created a moment that looks alive. The physics behind it is straightforward: ultraviolet light, carbon molecules, fluorescence. But the meaning it carries, that's human. That's our instinct to find kinship in color, to see connection where there should be none. Every culture has attached emotion to green: renewal, peace, curiosity, even jealousy. But in space, stripped of symbolism, it becomes something purer, an echo of home. When astronauts see green auroras ripple over Earth, they often describe an ache in their chest, a reminder of everything living below. Maybe the same thing happens when we look at 3i Atlas. We don't just see color, we see memory of oceans, forests, the first sprouts of creation. The irony, of course, is that the green of 3i Atlas comes from lifeless carbon reacting to light. But maybe that's the point, that life and non-life are not opposites, just phases in the same story. The same molecules that glow out there are the ones that built us here. Every flash of green is a reminder that we and the stars share chemistry. We are made of the same restless dust, trying endlessly to shine. So when we call it the color of life, maybe we're not being poetic. Maybe we're being precise. Because even in the blackest corners of existence, green still finds a way to appear. Not as proof of life, but as its promise. Among all the data streaming from 3i Atlas, certain molecules kept appearing in its signature: carbon chains, methanol, hydrogen cyanide. They sound cold, even toxic, yet in the language of chemistry, they are the letters of creation. These are the precursors, the compounds, that when mixed and warmed under the right conditions, form amino acids, sugars, and eventually the scaffolding of life. It's extraordinary to think that in that icy green cloud, drifting between stars, the potential for life's ingredients may already be dancing. Scientists are cautious, not claiming life, only possibility. But it's enough to spark wonder. If comets like 3i Atlas travel between systems carrying these molecules, then the seeds of biology may not be local to Earth at all. They might be universal, sown like pollen across the galaxy, landing on planets when conditions align. Some call this the panspermia hypothesis. Others simply call it beautiful. The idea that everything living shares one cosmic chemistry, one luminous origin written in carbon and light. Spectra from 3i Atlas confirmed faint traces of methanol, a simple alcohol that can form naturally in interstellar ices. Hydrogen cyanide, though deadly to humans, is one of the key components in prebiotic chemistry. Together, they form the backbone of organic synthesis. In other words, within that glowing emerald haze are ingredients that, under the right warmth, could one day breathe. It's poetic in a scientific way. that something drifting through the dark might carry the same molecules that make us alive. The green we see might not only symbolize life, it might contain its earliest whispers. When ultraviolet light hits those compounds, it doesn't destroy them, it energizes them. It's as if the universe keeps practicing creation over and over, everywhere it can. And maybe that's why comets have always felt mysterious to us, because instinctively we recognize their role. They are couriers, they are carriers. They bring chemistry to the barren, light to the frozen, and possibility to the forgotten. 3I Atlas is just the latest traveler in that infinite exchange, carrying not life itself, but the quiet potential of it, glowing green so that we might notice. When we see the glow of 3I Atlas, we're not just seeing light, we're seeing history. Every photon that reaches us was born in a different place, under a different star, and it has traveled an unimaginable distance through the dark to find our eyes. That journey alone transforms light into something sacred. It's not just radiation anymore, it's time made visible. The glow you see tonight may have begun its path before the first humans walked the earth. Imagine it, light leaving an alien sun absorbed into frozen carbon ices, sleeping for millions of years inside a drifting comet. Then, finally, as it nears our system, that light is awakened, scattered, transformed, released again into new color. In that moment, the past becomes present. We are literally watching ancient starlight, reborn as emerald fire across the edge of our sky. This realization shifts something inside you. The mind becomes quiet, the heart slows, because it's impossible to see that kind of distance, that kind of endurance, and not feel awe. Light that old shouldn't feel this alive, and yet it does. The photons, once lost in cold space, now dance again, their only purpose to remind us that nothing ever truly vanishes, it just changes form. That's the hidden poetry of astronomy, that looking up is also looking back. Every color is memory, every shimmer a survivor of time. And when we stare at 3I Atlas, we are, in a way, witnessing the universe, remembering itself, remembering that beauty, no matter how far it travels, never fades completely. Perhaps that's why it's so haunting, because while the comet will soon leave us, its light, the story of its journey, will linger in our collective memory. For a few nights in human history, we were connected to something timeless. And that connection, like the glow itself, will outlast us all. There's a peculiar intimacy in how we respond to green light. Unlike red, which stirs passion, or blue, which invites calm, green exists somewhere in between. The balance point of vision, the equilibrium of emotion. It's the color our eyes are most sensitive to, the wavelength our retinas evolved to trust. That's why when something glows green in the dark, we don't just see it, we feel it. It hums softly against the mind like a note we've always known. When people describe 3I Atlas's glow as alive, they're not being metaphorical. Green sits at the center of the visible spectrum, the point where the human eye perceives light most vividly. It requires the least effort to see, which means our brains give it the most attention. That neurological preference, born from millions of years of survival among leaves and grass, now colors how we see the cosmos. The universe painted this comet in the one hue our species could never ignore. There's also an emotional pulse hidden in that perception. Studies show that green light can steady heart rhythms, lower anxiety, even soften breathing. Maybe that's why, for some viewers, 3I Atlas doesn't just appear beautiful, it feels healing. The body recognizes it as safe, even if the mind knows it's born from radiation and ice. It's a quiet paradox, the color of life emanating from the edge of deathless space. Artists, monks, philosophers, all have tried to define why green soothes. Maybe it's because it bridges opposites, warm and cool, light and dark, heaven and earth. In the same way, 3i Atlas bridges distances in between stars, between meanings, between what we can explain and what we can only feel. It's light as empathy, meeting us halfway across the cosmos. And so when we look at that glow and whisper, it feels alive, we're not wrong. Life, after all, is not just breathing, it's responding. And we are responding to light that travelled across time just to be seen. In that instant, both we and the comet are alive together, sharing the same wavelength of existence. Space, for all its grandeur, tends to repeat itself. Stars form, die and form again. Comets circle, planets spin, dust drifts. Everything follows law. Predictable, measurable, logical. But every now and then, something like 3i Atlas appears and quietly reminds us that normal is only what we've seen so far. Beyond that, there's always something stranger waiting to be found. 3i Atlas doesn't behave the way comets should. Its orbit is foreign, its glow unpredictable, its chemistry unfamiliar. Yet in those deviations lies its brilliance, because it teaches us that the universe is still creative. It hasn't run out of surprises, it's still experimenting, still composing new versions of beauty through physics we don't yet understand. Scientists often talk about anomalies as if they're errors, data points that don't fit the pattern. But anomalies are often beginnings. 3i Atlas challenges our definitions not by breaking rules but by expanding them. It says, maybe this too is possible. It's a quiet rebellion, not loud or defiant, but graceful, glowing softly in proof that the cosmos is more flexible than we think. When you look at it through that lens, the comet stops being an outsider and becomes a teacher. It invites us to let go of certainty, to understand that our models are just sketches of a much larger painting, a painting still in progress, still being brushed by time, light, and movement. And perhaps that's the lesson of 3i Atlas, that normal is a comfort but not a truth. Out there, nothing repeats forever. Every orbit is unique. Every glow is a first and last. The universe doesn't promise patterns. It promises change. And tonight, under the soft shimmer of a green light from another world, we're reminded of how beautiful that change can be.